So the second type of program flow that we're going to be talking about today is repetition. And repetition allows me to repeat the same logic over and over and over again. There's a variety of different repetition structures that we could use. We're going to start our conversation with the for loop. So the for loop, just like the if statement, is in lowercase. It has a condition and it is a bucket, so I have my opening and my closing braces. Whatever I want to execute when I drop into the bucket will be put inside of the braces. But the difference is the condition. On the if statement, there is just one single condition or a compound condition, but on a looping structure, we need three specific things. I need somewhere to start looping, and I need somehow to end looping, and then I need something that will change the condition that will allow me to stop looping. So for example, a for loop might look something like this. For int count equals 0, I'm going to start a counter variable at 0. So I'll declare it and initialize it to 0. The ending point is going to be where count is 10. So I'm going to loop as long as my counter variable is less than 10. But in order for us to exit the loop, I have to be able to change that condition. And so I'm going to change it by incrementing my counter variable once each time it moves through the loop. So let's try this out and see how it works. So I'm going to create a project called for loops, and I am going to create the basic structure of a for loop. So I'm going to say for, and we need a condition. The for loop is a container just like my else is. So I'm going to put opening and closing braces. The difference is on a for loops are really, really good at counting. And so I need somewhere to start my count, and I need some way to decide how to end my count, and then ultimately I need some way to change my counter variable. So I'm going to create inside of the parentheses on the for loop, I'm going to create a counter variable. I'm going to call it count, and I'm going to initialize it to the value of 0. This may look to you like I am declaring a variable, and that is exactly what I'm doing, but I'm doing it inside of the parentheses on the for loop. And then I'm going to follow that with a semicolon because that is an executable line of code. The next thing I'm going to do is I'm going to say as long as my counter variable is less than, let's say for instance 10. I'm going to continue as long as my counter variable is less than 10. That will be my ending point. But if my count starts at 0 and I'm going to continue to loop as long as my counter is less than 10, there must be something that changes the value in count. And so I'm going to, the third part of this is to change the condition. I am going to increment my counter variable by 1 every time I move through the loop. And so whatever I put inside the opening and closing braces will be the logic that is executed. So what I would like to do is just see what my counter variable is doing. I'm just going to create a print statement that just displays what my counter variable is doing. And I don't want to just blindly throw a number on the screen, so I am going to put a text field in front of it that says that it is my counter variable. So let's just see what this does. And when I run it, the expectation is that my counter variable is going to start at 0. It is going to do whatever is inside of the bucket, and my bucket says print out the counter variable. So it's going to print out 0. Then it's going to increment my counter variable. It's going to see if the condition is still true. Is my counter variable still less than 10? Well, yes, it's now 1. So it's going to execute the loop again, which means it's going to print the new value of my counter variable. Then it is going to increment my counter variable by 1 so now my counter variable contains 2. It's going to evaluate the condition again. If the condition is still not true, it's going to execute the logic inside of the for loop, and it will do this over and over again until such time as the condition is no longer true. So I want you to notice that it ran from 0 to 9. And I said my counter variable less than 10. Why didn't it print count equal 10? And that's because I used the less than symbol. If I wanted to include the 10 in there, I would have changed it to count less than or equal to 10. And now when it runs, it will include the 10. So for loops are really, really good at counting things. They can count up. All right, so let's do another one. Let's see if we can actually count down. So this time I'm going to add another basic structure of a for loop. And then I'm going to put inside of here, let's create that counter variable. This time I'm going to set it equal to 25. I need that semicolon because that is an executable line of code. And I'm going to continue to loop as long as my counter variable is greater than, let's just randomly choose the value 3. And then the next one is I want to count down, which means instead of adding 1 to my counter variable, I want to subtract 1 from it. So if the plus symbol will increment it by 1, we're going to find out that the minus symbol will decrement it by 1. So inside of here, I would just like to display my counter variable again. So if you don't mind, I'm going to steal that print statement to put inside of here. And let's see if we can run it and see what happens. I did put a print statement between the 2 runs of the program just to try to separate the 2 loops. So here we go. There is the separation of the 2 loops. My counter variable started at 25. The count minus decrement it by 1 every time that it's used, and the condition is continue to loop as long as that value is greater than 3. So if you'll notice, it looped until it was 4, and as soon as my counter variable became 3, well, 3 is not greater than 3, so it dropped out of the for loop. So you see that I can count up, I can count down, I can count up by more than just 1. If I use the plus or the minus, that changes my counter variable by 1, but I can count by more than just 1. So let's do one more, and let's see if we can count by something besides just 1. So I'm going to build the standard format of a for loop. Inside of here, I'm going to create my count variable. I'm going to set it equal to, let's set it equal to some beginning value of 6. I'm going to continue to loop as long as my counter variable is less than or equal to 15. I'll put my semicolon on the end of there. And this time, instead of using a count plus to get from 6 to 15, I'm going to increment or count by 2s. Well, unfortunately, there is no shortcuts by counting by something that's not 1. So I'm actually going to have to say count plus equals 2. And this is my shortcut to add 2 to my counter variable each time we move through it. If I wanted to count by 5s or 15s, or if I wanted to count down, I could actually subtract 2 or 5 or 15. All right, so once again, let's just see what my counter variable is doing. So I'm going to copy and paste that in there. I am going to steal this print statement just to separate the runs of each one of these loops. We're going to run it one more time and see if we can count up from 6 to 15 by 2s. There we go. We started at 6. We didn't reach all the way up to 15 because when it added 2 to 14, we dropped out of the loop. All right, let's see if we can see a practical use for this for loop. How about if I were to prompt the user for a number and I would display all of the squares starting at 0 all the way up to the number that they enter. So let me write a little bit of pseudocode. The first thing that we would like to do is prompt for a number and capture the number. And the next thing that we would like to do is display the squares from 0 all the way up to their number. So in order to be able to do this, I'm probably going to have to create a variable to capture their number into. And if I'm going to capture their number, I'm going to have to create a scanner. And if I am going to declare a scanner, I'm going to have to import the scanner. So the next thing that we should do is we should prompt for the number, and we're going to capture that into that variable that we created. And then we're going to display the squares from 0 to the user's number. What that means is that I want to start with 0. 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and I want to continue this up until I reach the user's number. If I want to repeat the same logic over and over again, I should probably use a for loop to do that. So we're going to create a for loop. And inside of here, I would like to begin at 0. So I'm going to create a counter variable. I'm going to initialize it to 0. I'm going to loop as long as my counter variable is less than or equal to the number that the user wants to go up to. So that value is number. And then I'm going to increment my counter variable by 1 each time. So you find out that my begin value for my counter and my ending value for my counter do not have to be literal numbers. They can be variables as well. And so while I'm inside of here, what I would like to do is I would like to display 0 times 0, then the next time 1 times 1, and then the next time 2 times 2. And so what I'm going to do is just display the counter variable multiplied by itself up until we reach the user's number. And I want to say to the user, 0 squared is 0, 1 squared is 1, 2 squared is 4. So I'm going to build that print statement using my counter variable. And I can get the square just by multiplying my counter variable by itself. So let's run this and see what we get. It's going to ask me for a number. 5 squared should take me from 0 squared all the way up to 5 squared. There it is. If I run it again to 25, now it's going to do all of the numbers from 0 up to 25. So a for loop is really, really good if I want to count. Count up, count down, count by 2s, count by 45s. If I want to count, or if I know how many times I want to do it, a for loop is very good at that.